Good morning. So yes, I would like to talk about gRPC with you. And actually, I'm going to talk about something that you probably don't care about. Well, developers, as a developer, you shouldn't have to care about the RPC technologies. So, fun fact, when I sent the proposal to the JFocus committee late last year, a few days later, I watched a talk from KubeCon, and there was a quote that appeared. And that made me thinking, it's like, I mean, yes, developers shouldn't have to care, or don't care. Clearly, though, some of the developers do care. That's why I guess you're here this early morning to listen to me talk about gRPC. And I mean, let's face it, in practice, we usually have to care, because things are not as nice as we want them to be, so we have to go down into the nitty-gritty details of the foundational technologies. So, my name is Matthias. I work at Spotify in the infrastructure and operations group, or department, and I lead a team that is responsible for the service intercommunication in the backend. So, at Spotify, we have a bunch of developers and teams, and many of them builds backend services. My team builds tools and infrastructure for those developers to build their things. And recently, we've decided, last year actually, that gRPC is the future to go for us as well, even though it's not. It is developed by Google. And I would like to talk to you about that journey. The journey is far from over. We're still in the middle of it, but I would like to talk to you about why we made that journey and what we've learned so far. So we'll talk about a little bit why did we decide to move over to gRPC. We'll talk about what exactly we want to use it for, and then how we go about migrating something as foundational as an RPC framework in our backend. So let's start out with talking a little bit about what our infrastructure looks like. Roughly speaking, we have about 2,500 backend services that communicate with each other. So it's a rather large network of services that depend on each other and talk to each other. Roughly 1,000 developers work on that infrastructure or backend in about 250 teams. And this is actually quite hard to measure. We actually have a whole team trying to measure those kind of things, because what is a service? What is a developer? I'm an engineering manager, but I do push code, so am I considered a developer or not? So that's why I have a rough estimates. Those are I pulled them from last week. When I did the first draft of the talk, the numbers would look quite different than it was just a few weeks ago. Mostly our services are written in Java and also Python. We do have some odd ones and other languages, but those are our main languages that we use. The mostly used services in our backend, they use our proprietary backend, RPC, or protocol to talk to each other. Because why not have our own protocol? The protocol is called Hermes. It's not that kind of Hermes. The first time I heard about it, I thought about Futurama, Hermes Conrad. It's, of course, the name of a Greek god. Hermes is the Greek god that is the emissary and messenger from the gods, of the gods. We have been using Hermes for quite some time, and so Hermes is also known to be the divine trickster. And although Hermes has been a success for us to use internally, we do struggle with it nowadays, and that's why we're moving. So it has been tricking us, and that's why we really want to move on. It was written about 7 years ago. Hermes is based on ZeroMQ. Some of you might know ZeroMQ. That's an open source framework to build messaging infrastructure on top of it. Teams can decide to use JSON serialization or protobuf in the payload. It's not an RPC framework, so you can't directly compare it to gRPC, but it's more of a definition of how we do messaging and the protocol itself. Hermes is working great so far. If you listen or use Spotify, a lot of the control data, the data that your client, Spotify client, interacts with the backend is probably going to run on Hermes. We have a pretty resilient platform, and Hermes is definitely a big part of that. So why are we changing? The biggest push factor is really time to market. Is that when developers join Spotify, and they still do, they don't know anything about Hermes. We have to teach them how to use Hermes. When you want to stand up a new service that interacts with maybe 3 downstream services in our backend, most of the time you will have to write client implementations to talk to those other services. All that stuff is very, very costly, of course. So Hermes became this blocker for us to move faster. And of course also, I mean, when we moved to the cloud not that long ago, we realized we don't want to build data centers as our business. Likewise, we're not in the business of writing RPC frameworks or wire protocols. So the biggest pusher, I think, in the end, or like that, the biggest reason why in the end we said we need to get out of Hermes was the ecosystem, because it doesn't exist. If you use HTTP or any other open source tool out there, you can rely on tools and infrastructure that provided by other parties. We don't. So you want to use load balancers with Hermes? Nope, doesn't exist. You want to use caching? Yeah, write it yourself. You want to maybe use a shiny new service mesh like Istio? Not going to work. And also, maybe you're used to using curl. That's not going to work with Hermes. Or Postman, or any other kind of tooling or debugging tools that you use to, it just doesn't exist. Or if it exists, it was written by us. So the developer experience in that is really not ideal. So, in the grander scheme of things, it's really our push at Spotify to move from our own bespoke solutions, kind of not invented here syndrome, to adopting open source. We tend to think that it's not just not invented here, it's more of not invented yet. So many of the solutions we built didn't exist yet. We had to build because nothing else existed. So I mentioned that Hermes is a name of the Greek god. We have different tools that are named similarly that we have internally. So we have our own container orchestration system called Helios, also a Greek god, that we're now getting rid of in favor of Kubernetes. We have our own service framework called Apollo, also a Greek god, to build backend services with, that we hopefully eventually are able to move out of. So this is not it's really in the grander scheme of things, it's one step in that direction of getting rid of all those bespoke solutions in favor of third-party, open source, community-driven, and best practices. Okay, so why gRPC? Well, first of all, it's open source. It seems to be becoming a standard in many ways, and it has proven itself. But there's another reason, it's cloud native, right? Everybody's hyped about cloud native nowadays. Well, this is a joke, of course, but the fact that it's owned and by or supported by the Cloud Native Foundation, you see the logo there in the middle, actually gives some kind of safety. You know that there's a big organization behind it, so the Cloud Native Foundation is subsidiary or is a part of the Linux Foundation, and they make sure that gRPC as a project thrives without any, and it isn't controlled by just one single entity. It was founded, open sourced by Google in 2015, and Google built it in order to replace their own proprietary protocol that they have, Stubby, an RPC protocol. And since then, a lot of players in the industry have started using gRPC. Netflix is using gRPC, Uber is using gRPC, Dropbox, a lot of big players in the world out there. Very basic, gRPC is based on HTTP2, so everything that works with HTTP2 is going to be able to transport gRPC. That also means you can do request multiplexing, you can do header compression, you can do streaming bidirectionally, which is really nice. It's a binary protocol, so it's not used. You can use JSON with gRPC, but most people are going to use protobuf serialization. One big advantage with gRPC, or one big thing with gRPC, is that you have this service identification, the definition language, also in protobuf, where you define how your service looks like and how the API looks like. So this is like the central piece of gRPC APIs. We'll look at that a little bit further later. And from that file, from that protobuf definition file, you can generate code for multiple languages, and that, of course, helps you, so you don't have to write all that boilerplate code anymore. gRPC is also really strong on encryption. By default, everything is encrypted, and you have to actually opt out of encryption if you want to do plain text. It also supports authentication if you want to authenticate services talking to each other. So there's a lot of, gRPC brings a lot of things out of the box. I would like to look at a few, two topics that are particularly interesting for us and have proven to be valuable. So, first is the proto itself. I mentioned it, it's the protobuf, the service definition file, and this is really everything depends on that definition. That's where you define your API, and let's just look at an example. So, this is an example now of a protobuf file where let's say we would have, suppose we have a service in our backend that's called metadata, and you can query that service, say I want to know the metadata for a specific song. So in this file, I define a very simple API for that service. Well, in the very start, we start out with saying this is a specific version of protobuf. The latest one is Proto 3. You define a package name. Then we have a few optionals. That's because we happen to use Java, and those optional annotations help us create nicer Java code, but they're not necessary. And then we actually start with the service, the API definition. You see the keyword service and metadata, and in there's the methods that that service exposes. So we'll have only one method. It exposes a request response pattern, RPC method called getMetadata. You'll send in a song ID, and you get back a song metadata message. And the definition of those messages is also in the same file. So you have a message called song ID, that's just an ID, an integer, and you have a message song metadata, that's the response, that consists of an ID, a name, an artist, and an album. Very simplified, but this is already a complete description of an API. There's no more having to read code to make sure what exactly the request or response looks like. You don't have to read outdated readmes anymore. This is the source of truth. And from that, now you can create code in multiple languages. I think, if I go back, so at time of writing, those were the languages that were supported by the protobuf compiler, Proto-C. We mostly use Java, as I mentioned before, and Python, but there's others out there. So from that file, let's say we create a Java server code, and we can write client code, right? Let's look at, once we create the server code, let's, for instance, in Java, we can start using it by basically just creating a class. We call it metadata service class. We extend the generated class that comes from the compiler, and then we just have to overwrite that method that we defined in the API before. The method takes a song ID, and it sends back a response. And the response, we just fetch something from the metadata backend and send it back. This is a little bit of a contrived example, but it shows that the actual boilerplate we have the right to hook everything together is very, very small. All the serialization behind it, everything is hidden away from us. We don't need to care about that. On the client side, we might want to write a client in Golang, for instance. So we create stubs in Go and can then use that code, those stubs to call our metadata service. So in here, in this example, we have to set up the context first. We connect to the metadata service. And then once we have a service, we just send in an ID, 42, and hope that we get something back. Very little boilerplate. This is an example of a blocking RPC call. You can also do non-blocking asynchronous calls. And of course, as I mentioned before, it doesn't only have to be request-response patterns. It can be streaming. in any in one way or bidirectional. One other nice thing, so I mentioned the proto is kind of the source of truth, and in the proto file we had comments, and those comments are actually documentation that will also show up in the IntelliJ, in Java, for instance. So the Java doc for the get metadata method, for instance, shows the comments that were written in the proto file. So everything kind of nicely fits together. Okay, so a few things. Since I said that the proto file is so important, we came to realize quickly that we need to find a way on how to handle those schemas, those proto files. If you have hundreds of teams or thousands of developers, you want to make sure that you have kind of a consistent way to do that. The first learning we had was, well, we really need to make the proto file the first class, or the source of truth. We started out with first distributing artifacts with compiled client code to the different teams, and we realized that doesn't really make sense. It's the proto that should be the main artifact, and this is what we should be sharing, because then the client can decide how they want to use it, in what language and whatnot. And it's really easy to generate that code anyway. So the proto file is your API. That's the first learning. It should be your first-class citizens. Don't distribute SDKs or client implementation. You can also if you want to, but make sure that the proto is available. And then share it in one place. So, I mean, gRPC is from Google. Everything they built, a lot of the things they built are in monorepos, so they are used to work in that way. Especially in the beginning with gRPC, everything was really easy if you had monorepos. If you didn't, like we don't. We have multiple hundreds and thousands of repos. Everything kind of breaks down because proto files can depend on each other, and you want to have that file shared between a server and its multiple clients. So what we did instead, and we're not the only ones, multiple people have started doing that, is we have this shared repo that everyone uses just for the proto files. In our case, it's called shared protos. There we can have like foundational proto files where everyone depends on, but we can also, it's also a good place for people to search for APIs. And on top of that, we can build tooling to make it discoverable, and we can build on top documentation portals on top of that and things like that. Another advantage with a shared repo is that you can lint everything. If people check in, new change to the API, you can run a linter across everything. You can do backwards compatibility checks and you can enforce those kind of things centrally. And the third thing is, don't try to version the API outside of the proto files. So we were used to doing versioning on the SDK level, on the client code level, for instance, or in the server code. Instead, we realized that doesn't really make sense. We just rely on protobuf and gRPC to be backwards compatible, make sure that we don't make any breaking changes, and if we have to, we create a new API. Basically, we create a metadata v2. And that simplifies a lot of things. Otherwise, we went into that rabbit hole in the beginning where we basically started to reinvent versioning, and we ended up having to write dependency management, and it's like, nope, that's not what we should be doing. Otherwise, we're in the same rabbit hole again. Yeah, so one recommendation, Uber has written a tool called Prototool, which is great for linting and a whole bunch of other things if you work with protobuf files. So I warmly recommend that tool if you start using gRPC or already are using it. Okay, so another thing that gRPC is really valuable for and that we really get use of is its way to improve resiliency, or it makes it really easy to implement robust resiliency patterns. And with just a few examples. So one thing in gRPC is called deadlines. So instead of timeouts that you might be used to from HTTP or other services, you don't do timeouts, you do deadlines. As a client, when you call a server, you define how long you're willing to wait for that call to come back. And the deadlines will be propagated through the call chain. So here, again, we have an example with metadata. It's now metadata is 2 services. And the calling service, the ingress service, says, okay, I'm willing to wait for 2 seconds. And this is kind of this fixed time that you allow the backend to respond within. And the SLO, or the contract that the metadata proxy with its own backend has, might be, hopefully it's shorter than that, so they might have a deadline themselves. You can either rely on just propagating all those deadlines through the network graph, or we actually recommend to define deadlines in every call you make. We actually enforce people to always set deadlines. That's also a learning that we had made on the way. One advantage with that is, since not only us are using gRPC, but also others, especially Google, for instance, and we use Google Cloud, we can call Google's managed services with gRPC, and we can use deadlines there as well. We use the same protocol all the way, and this is also useful for metrics, for instance. If you do tracing, you get everything, not just in your backend, but across everything you use, as long as you use gRPC. Retries, that's not something particularly fancy, but gRPC has that built in, so you don't need to write that yourself in your client code. It's configurable, of course. But there's a specific version of retries which I think is quite unique. It's called the hatching, also called backup requests if you use Cassandra, or sometimes it's called speculative retries. So what you do here is you hatch yourself for low latency. So you hatch against low, and by that you just send out a whole bunch of parallel requests to all your backends and wait for the fastest response. Once the fastest response comes back, you cancel all the outstanding requests. So that is a really good way to cut off your, decrease your tail latency. So if you have one or two or a certain subset of your servers misbehaving, being slow, they won't affect your calling end because you just make sure that you fan out with all your requests. Downside, of course, that we create a whole bunch of more RPC calls. And that might be a problem. So if you have one service that is being hammered by a whole bunch of different upstream services, and it tries to recover, you have this thundering herd problem, right? Where the service tries to come up again, it's just hammered with a whole bunch of requests and retries from all over the place. And that is usually means that the service just falls over again. To mitigate that, gRPC offers multiple things. One of them that we started using is retry throttling, where you can define it in the client but also in the server you basically get allocated a retry budget. So if a client calls the server a certain amount of times, let's say, and then it runs out of retries, it just stops. It's similar in nature to exponential backoff if you use circuit breakers. It does a similar thing to prevent those kind of herding, to prevent cascading failures in a distributed system. Okay. Load balancing and routing is also an interesting field for gRPC. There's different versions of load balancing, of course. We currently use client-side with Hermes, because Hermes, we don't have any proxies that we can use out there. So we use only client-side load balancing, where every client knows of every backend and just, with a certain strategy, chooses who to call. It might be round robin, or it might actually try to figure out where it gets the best latencies. gRPC supports that out of the box. With gRPC, you can also do proxying. So proxying is basically server-side load balancing. The standard proxies out there, Nginx and Envoy, they already support gRPC. And then there's a third variant, which is kind of a combination of both. It's called look-aside load balancing. And I haven't seen that before we started using gRPC. So let's talk a bit about look-aside load balancing. Look-aside load balancing is very similar in nature to client-side load balancing, but instead of the client having to know about the backend, it has this look-aside load balancer, that's the blue box on the bottom, that informs the clients what the backend looks like. And then the backend, just with that updated, the list it gets from the load balancer, it will use that to do client-side load balancing. But that list can be continuously updated. It can be used So the local site load balancer is maybe monitoring how the backend looks like and removes unhealthy instances from that list centrally. Or you might use it to do routing if you want to run a new version. So you can do very sophisticated ways of routing with a local site load balancer. Okay, so how do we migrate to gRPC? This is quite a thing like moving over to gRPC is quite foundational. So how do you, across 2,500 services, how do you migrate? It's really a journey, right? And I said at the beginning, we're not done yet. So we're somewhere in between Hermes and gRPC right now, in the worst of both. We have both in use right now. In fact, if you look at our backend, this is how it looks like right now. We have, I mentioned before, roughly 2,500 services. It's a little bit more. A lot of them use HTTP, but the big high-volume traffic services that use Hermes, around 980 today. About 80 of them are migrated to gRPC. So we're not far yet if you just look at the numbers. But it took us some time to actually just lift off with the plane, so we still feel like we got quite far by now. And now the migration is becoming organic, more organic, and we don't have to do that much work anymore as in a central team. Or so we think. So we have about 900 services to go. And also, we don't want to necessarily migrate HTTP services, but what we really want to get rid of is Hermes. And then if somebody else also wants to use gRPC that is using HTTP today or something else, they might also want to do that, but that's not our main target. Migration itself is really a problem of change, right? And change is hard, because change is really threatening. It threatens what we find familiar, and what is familiar is usually what feels nice and comfortable. But it's not always the right thing, the familiar thing. So really changing something as fundamental as gRPC is really about change management and how to go about that. And of course, you don't want to force it. Instead, you want to have multiple carrots that you kind of make teams to want to migrate. It might be that they want to use code generation and try to writing boilerplate code. Or they might want to make use of the resiliency patterns built in. Or they might want to start using tracing, which we don't have in Hermes. Or they might want to use something as a service mesh, Istio. You have to give people reason to change, and it's just of beating them in the head. So one way one thing we do at Spotify is besides offering people carrots, we try to make the right choice the easy choice, so gRPC being the right choice. And instead of forcing everyone to use it, we just make it the easy way, the obvious choice. We have this thing called golden paths at Spotify. And the golden path is multiple things. So depending on who you ask, they will answer you differently. What you see here is our developer portal, a screenshot, and you have links to the different golden paths. It's actually, if you open it, it's just a document where it describes how we build services or data pipelines or mobile clients. But it's not just a document, it's also our blessed stack, if you will. And the guarantee is as long as you use the technology described in the golden path, you will be supported by the infrastructure teams. And everything kind of works out of the box. So once you bring something into the golden path, like gRPC, people will tend to use that more likely than other things because it's just the easier way to go that way. That's a block example from our internal Stack Overflow. Somebody asked, what's a good strategy to migrate my service? So this is another way to just make sure that people feel like that they're supported, and we can help them wherever they are with moving to gRPC. And in the end, it should be on their own. Our main goal is that they can move by themselves. You also see on the top right corner that my little profile there, I only have a reputation of 1, so I'm not very active on Stack Overflow, unfortunately. A third thing we need to do, especially in the beginning, is kind of unblock the early adopters. So we have a lot of teams that are very eager to use gRPC because of multiple reasons. And so our first approach was to support them and unblock them by building the tools they needed in order to get going. That was kind of to get the momentum started and get the ball rolling. And then the second thing we did was when we looked at the backend, we saw there's a dozen, maybe not even a dozen, a couple of services that are used by many, many clients. So I mentioned the metadata example. That's actually a group of services that we have at Spotify that are used by hundreds of clients. And there's also dozens of implementations of the clients. So we should tackle those first. And once we migrate those services, everybody else can start using gRPC. As long as we don't migrate those services, everybody will be blocked by using gRPC, from using gRPC. So this is really strategic to invest in those services first, and that's something that we centrally can actually support those teams that own those services by doing the work together with them. So late last year, we did have our metadata proxy being migrated to gRPC, and this is the first example that was queried. And this is just a screenshot from our Slack channel, where 2 people from my team are working on gRPC of the metadata service. Yeah. So second challenge is it's similar to the first one, is that we really don't want to end up with we just have yet another protocol. So instead of just having Hermes and HTTP, we now have Hermes, HTTP, and gRPC. And to put it differently, this is really, we don't want to end up having this never-ending migration. And there's 2 variants of this. One of them is that we have a lot of services out there that are maybe not well maintained. So who is going to migrate those? So this has a long tail of migration. That's one thing, and that we can fix by gamification. We make sure that we visualize the migration progress and incentivize teams that migrate quickly with perks. They might get socks with gRPC logo, or they might get a sticker for the laptop, or they might get a badge in our internal portal, things like that. A second version of the never-ending migration is that services that start using gRPC, what they do first is they add a gRPC API, then they ask all the clients to move over to it, and then they kill the old Hermes API. But that second step is really the hard one. This is where people get stuck. Because how do you force, if let's say you have a service that's owned by 100 that's called by 100 different services, how do you force those service owners of those services to change? And that's where maybe not always only carrots help, but sometimes you need to have a stick. And that stick could be you set up a timeline. You say, okay, by the end of the year, we'll be removing that API. And basically, you just introduce end of life and end of support timelines. This is something that people are not really used to, so that's something also that we can help centrally by providing guidelines or templates on how that communication could work. Third, and that's maybe also the third challenge that we have in migration, that's also the challenge that we really haven't solved that well yet, is the developer experience. gRPC is a binary protocol, so one thing that people will run into right in front of bat is, okay, how do I grep through a request? How can I curl something and just look at the JSON payload? That's what people are used to. The good news is that the gRPC ecosystem is very vibrant. There's a lot of development going on and a lot of new things coming out, but that's still something that we need to work with. We do have one advantage, I guess, compared to many others, that we have Hermes, which doesn't have a great developer experience either. So people's expectations are maybe a little bit lower than what you might have. But in the end, in that journey, we don't want to end up with something like that, where we reached the goal, but the experience was horrible. Really, what we want to do is this. We want to have a straightforward migration from Hermes to gRPC without a lot of friction. And coming back to the quote from the beginning, well, developers don't care. I would change that to say they don't have to care. And if we manage to do that, where people don't have to care anymore what kind of gRPC technology they use, that's when we were successful with our migration. Thank you. know there's still quite a lot of time left. I think I would like to take questions if you come down here and we take them one-on-one, or you can take questions by reaching out to me on social media. Otherwise, I think there's coffee break coming up. Thank you.